and calculus, I think that one is not a problem. But for this, uh, it's just too much. So we'll try and see. But please try and then bear with me. Today I have to rush a little. I have to rush a little. So please, 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 try and bear with me. It's just unfortunate that some of you did not read elective math. So even when we teach the notes, some of you are still not able to get the concepts. But you said you want to do this course. So you have to look for the way out, the way to understand and others. Because not most, all the things that we are doing right now are in we are supposed to do them in SHS. SHS. That is unfortunate that because it's supposed to be a form of revision. And even those who did them at the SHS, they didn't take their time to understand whatever they were taught. But it's all the same, I'll try. But at least those who did elective maths will be able to at least remember something. But those who did not do elective maths will be a little bit difficult. But I was expecting you, since you have the notes already, to read ahead. But I don't know. So please try and read ahead. And if you have challenges, you can give it to some other friends. Maybe if you know any SHS teacher somewhere, or even some students, SHS students should be able to help. So please try and then help yourselves. Okay. Because what I'm doing, I don't think it's about reading the notes, but I'm not reading the notes actually. Those who understand know that I'm not reading. We are solving questions. So please try and understand what you're going to do here. So last week we started with the real number system. We saw that it's a combination of rational numbers and irrational numbers. And then under rational numbers, we have other numbers, counting numbers, integers, and others. And then the irrational numbers. And then we solved this that to show that root 2 is an irrational number. We did this. And we saw that b squared is even, ab is even, a is even. So it cannot be rational. We used, we proved by contradiction. So you can prove by contradiction, contrapositive, and others. So contradiction, you just say that root 2 is a rational number. And then you prove that it's not a rational number. So that is proved by contradiction. And then we also looked at axiom of order. Okay, we looked at all these. So today we want to look at the number line, and we all know number line. We started that dealing with number line even at the primary school. I remember my kids, even my class 1 daughter, she brings number line problem to us. So, and I told you that whatever you learned at the KG is the same thing, because KG we're told that 1 + 1 is 2, and it's still 2 even at the university master's PhD. So number line that you know number line is still the same. Okay, so you're looking at the number line, but under the number line, we'll look at absolute values. Absolute value. Okay, so we are saying that the distance between the point A and the origin is denoted by this. So I think last week I don't know, I think it was the analytic geometry and calculus class that I defined roots of a number for you. That if I have absolute A, please can you hear me?
Yes, madam, you can hear you.
Yes, madam.
Yes, we can hear you.
So I said that absolute A, this thing we read it as absolute of A, or is the same as modulus of A. And this is, you're going to get two parts. So I said that when you substitute absolute of negative number is positive, and then absolute of a positive number is also positive. So when I have absolute of A, I can define it as A plus A if my A is greater or less than 0, and then I can have negative A because I'm telling you that absolute of negative A is positive A, and then absolute of positive A is also, sorry, I'm coming again. Absolute of positive A is A. Absolute of negative A is A. So when I have absolute, then it should be both positive and negative. Negative will mean that A is less than 0. Positive will mean that it's greater or equal to 0. So for example, absolute of negative 2 is equal to negative, which is 2. Now note that distance between 0 and 1 is the unit distance. Okay, so if I want to sketch the graph of y is equal to root of x, I just told you, it means that I'm taking both the positive values and the negative values of x. Okay, but the y value that I'm going to get will be positive. Okay. So if I have y is equal to absolute of x, I can choose positive maybe 2. So the y value will be absolute 2, which is equal to 2. If I take negative, s is equal to negative 2, so that's s equal to 2. I'm going to get my y value to be absolute negative 2, and this will give me 2. So the graph of this function will be, so my 0 will be 0, and all the positive values will be positive, and then the negative values will still be positive. So we have negative value for x, but the y values will be positive. So this is the graph of y is equal to absolute of x. Please, today, as I said, please try and follow. Try and follow. So you have a lot of things to do. I think, I don't know, is Madam Monica here? Who is here? Is it Monica or Samuel from Code? Who is here? Monica or Samuel? Do we have someone from Code?
I think so. I think I've seen code here as well.
So by how many weeks are we treating this? Is it 4 weeks
4 weeks.
or 6 weeks? So if it's 4 weeks, it means that we are supposed to finish next week. And we are even not done with the first 3 weeks. And I think after next week, I owe you some hours. So I'll try and then get that for you, because the first day I was not feeling well. So I did only 1 hour. So I'm owing you 3 hours. So I have to look for a time so that we meet. And then possibly maybe I have to talk to my tea if she can meet you within the week or something, maybe, so that she can also help in a way, because we've not done much and we have to finish. Okay, so as I was saying, that is that. So we have some theories under the absolute numbers. So if I have numbers A and B, where both are real numbers, so I told you now, if I have numbers which are real numbers, then I will just write A comma B in R. So if A and B are in R, this means that A is a real number and then B is a real number. Then we have the following theorems. It says that A is less than or equal to the absolute of A. So if I have a number A, it is either less than or equal to the absolute. So when we take the positive, it will be the same, but when we take the negative, it will be less than or equal to. And then the absolute of the product of two numbers, A and B, is the same as finding absolute of A, and then finding absolute of B. And then also absolute of A minus B is the same as absolute of B minus A. So please note that it should be noted, it should further be noted that absolute of A minus B is the same as absolute of B minus A, which is the distance between points with coordinates A and B. So please note that. So absolute of A minus B, which is the same as absolute of B minus A. We call it the distance between 2 points A and B. Then the absolute of A minus B all squared is the same as absolute of A minus B. So this one is not, this absolute of A minus B all squared is the same as A minus B in a normal bracket squared. Please, you need this theorem because when we get to some points, we will not come back, but you should have them. You should have them in your head. We'll be applying them. Okay. Then the square root of A squared is the same as absolute of A. So example is this, square root of 4 squared is equal to absolute of 4, which will give me A is equal to square root of 4. And you know square root of 4 is 2. So the square root of A squared is equal to the absolute of A. This is for A greater than 0. Okay. And then square root of negative 2 squared is the same as absolute of square root of 4. That's also for A less than 0. And this one will also give me 2. Okay. So we are beginning with solutions. It says that we should solve for x if absolute of x minus 2 is equal to 1. So I want to solve this. So I told you that the definition for this, absolute of x minus 2 is equal to, we'll have the positive side, which is x minus 2, if x minus 2 is greater or equal to 0. So this implies that my x is greater or equal to 2. And then I have the negative side, which is negative into brackets, x minus 2. This means that my x minus 2 is less than 0. So it means that my x is less than 0. So to solve this, we look at the positive side. So I have positive side, I have x minus 2 is equal to 1. And making s the subject, I'm going to get my s to be 3. And then also the negative side, negative of x minus 2 is equal to 1. Then this one means that when I solve this, I'm supposed to get s equal to 1. So the truth set is x such that s is equal to 1 or 3. So we have what we call truth sets. Yeah. Yeah, please, your hand is up, Michael.
Yeah, madam, why x minus 1 equal to 1?
Is it x minus 1? We have x minus 1.
X minus 2 equal to 1. Sorry, madam.
Michael, were you following? It's a question. The question says that we should solve for x if absolute of x minus 1 is equal.
Okay. Because of the networks, I just joined. Sorry, madam, I've seen. Thank you.
You're welcome. So the truth set is s such that s is equal to 3. Okay, so please you have to note this one too. That the absolute of A is less than or equal to C implies that my A lies between negative C and positive C. This is where C is greater than or equal to 0. Now, absolute of A greater than or equal to C implies that my A is greater than C, or my A is less than or equal to, greater or equal to C, or less than or equal to minus C. Please take note of these because we'll be using them. Okay, they are theories. Then we come to the second theory. It says that if I have A and B, which are real numbers, then I have the following. That the absolute of A plus B is less than or equal to absolute of A plus absolute of B. Then absolute of A minus B is greater than or equal to absolute of A minus absolute of B, please. And then the absolute of A minus B is less than or equal to absolute of B minus A. It says that we should recall from theory 1 that if I have plus or minus 2AB, it is less than or equal to absolute of 2AB. Okay, so I think it is somewhere here. Okay. So it is less than or equal to 2AB. Where do we have 2AB? Okay. So this thing, so the theory 1 we are using is here. That's absolute of AB is the same as absolute of A, and then absolute of B is up there. Now this one, plus or minus absolute of A, A 2 times AB is less than or equal to absolute of 2AB. Okay. And this is the same as bringing the constant out and then writing the AB in absolute. And this implies that I have 2AB. So if it is minus and positive, then 2AB will be greater than or equal to minus, then I have 2AB. So now applying previous theory, we have, so the previous theory, we were told that A minus B squared is equal to, absolute is equal to A minus B all squared. It is something. We want to prove something. So we know from here that this two, that the absolute of A minus B squared is equal to A minus B in a normal bracket squared. So that's what we are using to prove this. So please, we have this in mind. Then we want to prove this. So A minus B absolute square is equal to A minus B in a normal bracket squared. And then we know from maybe SHS or anywhere that this expression is the same as A squared minus 2AB plus B squared. Okay. And we know that this up there, this can be written as absolute of A squared. And then we just saw that, so the whole of this will be greater than or equal to from up here. This will be greater than or equal to 2 absolute AB plus absolute of B. And this expression is the same as absolute of A squared. From up the first theory, we know that absolute of A, so this absolute of AB is the same as absolute of A times absolute of B. So if I have two or absolute of 2AB is the same as bringing the 2 out and then having absolute A, absolute B. So that's what I have here. So instead of writing 2 absolutes of the product of A and B is the same as writing it as 2 absolute of A, absolute of B, then plus absolute of B squared. And if I want to write it in this form, I can write it as absolute of A minus absolute of B in a bracket, all squared. That's one of the proofs. We have others. I want to skip this because I don't want to disturb you this morning. You can take your time and then read through them. So the same thing, it's continuation of the proof, but I don't want to disturb you, please. Hello. Yeah. Yes.
Please move to the last slide. There's a certain tool there. It vanishes at once. I didn't see it again.
This one.
Yeah. Yeah, the 2, the minus 2. The second step is not there. And then I don't know the reason why it vanished.
Is it here? Is it here?
Yeah, the 2
where
there.
The cursor?
Yes.
Abu, I'll beat you. or B2.
That too, I don't know where.
It hasn't vanished though. So I will just write what I have there and then I'll ask you to expand. Abudu, can you expand this for me? Expand this for me.
Madam, you get A minus B all into bracket times A.
There's one in the count.
Okay, so I know it's that, but this one will give you a squared. But we were told that it will be a squared times 2 times a times b. So a squared minus 2ab plus b squared. You know this.
Yes.
Okay, so using this, expand this for me. What will be the what do I get when I expand this?
Madam, I am confused.
You know that when you expand a minus b all squared is the same as a squared minus 2ab plus b squared. Is that not it?
Yes, madam.
So in place of a, I'm bringing absolute of a. In place of b, I'm bringing absolute of b. So use this, and then expand this one for me. Use this idea to expand this.
So this one too will be a square minus 2b.
But remember,
2ab
this is
plus.
a. This is, I have to take your time. This is a, but here it is not a. It's absolute of a. So what should I write here?
By okay, at the top there you say that the absolute of a minus absolute of the b, you can write all square. You can write them as a minus
I know,
b all
no.
square.
Please no. I said that we are using this to expand this. So please use what we have here. Here in place of a, I have absolute of a. So please use this and then expand this. You get that one from what will you get?
Then, madam,
Please, can
I have
someone
to look at it.
Hey, Abdul. Please, can someone
Yeah,
help us
then I
with that
was.
one?
Hello, madam.
Then I was. That's why.
Square.
Yeah, first, what do we get?
So we'll be getting the absolute of a squared
Absolute of
Minus 2.
a squared
minus
minus
2 absolute of a absolute of b.
absolute of b.
Then
Plus.
absolute of b squared.
It's not bad.
So this is what you saw. You saw absolute of a squared minus 2 absolute of a absolute of b plus absolute of b squared. And in place of this, I can write, so this is the same as absolute of a minus absolute of b all squared. So Abdul,
Yes.
I know that absolute of a squared minus 2 absolute of a absolute of b plus absolute of b squared is the same as absolute of a minus absolute of b all squared. It's a confusion if it's from where?
Yes, madam. Thank you, madam. I've seen it.
So, welcome.
Thank you, madam.
You're welcome. Okay, so we'll skip the proof and then continue. Example, you want to solve for x. If I have absolute of x minus 5 less than or equal to absolute of x plus 1. Okay, so here we have two options. The first option is we know that absolute of x minus a, so we use this method. Where is it? That the absolute of a is less than or equal to c means that a lies between negative a and positive a. So when I come here, I will choose, so I'll have this, the absolute of this will be less than or equal to this. I will have that one. Then after that, I will pick this and then also have absolute of, because both of them are absolute numbers. But in the first theory, we have a simple way of going about it. The simple way says that, so the first theory, it says that absolute of a minus b squared is the same as normal brackets a minus b all squared. So to solve this, I will square both sides. To solve this, I'll square both sides. When I square both sides, I have absolute of x minus 5 squared less than or equal to absolute of x plus 1 squared. And we just saw that this is the same as the normal bracket. So I have x minus 5 squared less than or equal to x minus 1 normal bracket squared. Okay, so to solve this, if you want to solve this, then I'm bringing this one to the other side. So I'm going to get x minus 5 squared minus x plus 5, x plus 1 squared. You can just open brackets, whichever way you want to solve it, you can solve it. Okay, so it's not by force that you use my method. So you can just expand this one, you expand this one, you simplify, and going to get the same thing. But I'm seeing this as a difference of two squares. I'm seeing it as something like a squared minus b squared. If it is a squared minus b squared, I can write it as a minus b and then a plus b. This is how I am solving it. So where the first term is my a, and then the second term is my a. Okay, so I write it as the first term minus the second term in one bracket, and then first term plus the second term in one bracket. This is how I am solving it. But you can expand this, you simplify, and you're going to get the same thing. Okay, so if I solve it like that, then this s can go with s. Then I'll be left with negative 6. Stephanie.
Madam, why is it the x minus x plus 1 all squared? They have made the sign all positive.
Where is it?
The x minus 5 all squared minus x plus 1 all squared. The expansion, they are all positive.
Is it here? Is it here?
Yeah. Yes, ma'am.
They are
With the
all
expansion
positive.
under the, with the expansion
So we
under.
I have x minus 5 minus x plus 5.
Okay,
X,
I get it.
then
It's
I have
okay.
x minus 1. So difference of two squares. Okay,
Okay,
so as I said, okay, you're welcome. So this will give me minus 6. Okay, and this one will give me, I have x plus x, which is 2x. Then I have 5 plus negative 5 plus 1, which is negative 4. So I have 6 into bracket 2x minus 4 less than or equal to 0. So you take your time and simplify, divide through by negative 6. Then the sign will change to greater than. Then after that, you divide through by 2, which will give you. Yeah. Please, you can talk.
Madam, please, under which condition would the sign change? Because with this one,
Hey,
um,
this one too, you were asking me. Under what condition would the sign change? Don't do that, please. Don't do that. I have minus 6 into 2x minus 4 greater than is less than, not greater than. Less than or equal to 0. So you were told, even the SHS, that when you divide through something by a negative number, so I divide through my negative 6, and this will go. So I have 2x minus 4. Since I'm dividing through by negative, this sign will become greater than that. You don't know this. I don't want to go through any. But this one, you don't know this. Do you know this? Hello? So you are dividing.
Madam, she's afraid of you.
Why is he afraid? Like, so you don't know that when you divide through this signs by negative, it changes even from somewhere. So since we are dividing through by negative 6, this one will change. We know you were told this one somewhere. So you divide through by 2, so you're going to get x minus 2 greater than or equal to 0. So solving, I have x greater than or equal to 2. Please, what you learned at the basic school, JHS, SH, you cannot forget them. You are bringing all of them here, please, everything here. So some things are just basics, and so please, if you have forgotten, you can even take the children's math book and start reading, please. Okay, so that's how to go about questions like this. Okay, so something like this, you square both sides. Something like this, you apply the theories. Okay, so let's continue. We want to look at intervals. So let A and B be points on the number line. A greater than, less than B. Then we'll have the following intervals defined on them. We have what we call closed interval. So please, in mathematics, when you see something like this, we call this one closed interval. And this one is the same as x such that x is greater than or equal to A. So please take note of this. S is greater than or equal to A, and then x is less than or equal to A. This means that when I take this interval, my A is part of what I'm looking for. My B is also part of what I'm looking for. But I'm looking for, and then numbers greater than B, greater than A, but less than B are all inclusive. So when I have something like this, what you learned at the basic level, please, and open your eyes to, because I told you that we don't have time. Okay, so if I have interval like this, 1, 5, something like this, this can be written as x such that I have 1 less than or equal to x less than or equal to 5. This. When I write this one, it means that I'm looking at values from 1. So the set I'm looking for, the interval, okay, so it's an interval. Or I can write it as something like this. What I'm looking for, I'm looking at 1. So numbers greater than 1. I want to write only integers, even though I have this, but I want to write only integers. So it means that the set I'm looking for, 1 is parts, 2 is parts, 3 is parts, 4 is parts, and then 5. That is the interval I'm looking for. 5. So numbers greater than that. Okay. Then we come to open intervals. When I have open, so this one, please take note of the brackets. This one is square brackets. This is the normal bracket. When you see something like this one is x such that x is greater than, so it is strictly greater than A and strictly less than B. So when I have something like this, 1, 5, this bracket open, this one is such that S is such that S is less than 1, greater than 1, and then less than 5. So this one, when I take the only integers, it means that I'm looking for numbers like 2, 3, 4. 5 is not part, 1 is not part. When it's open like this. Then we have what we, okay, so we'll move on to, it says that the length of either interval is b minus a. We even mentioned this one up there. So that is that we have the open interval and then the closed interval. If it is open, then the endpoints are not part of what we are looking for. If it is closed like this, then the endpoints are parts. Are you okay?
Yes, madam.
Yes, madam.
Yes,
Yes.
madam.
What's here? You know, I drink class 1 and class 2 because we are bringing class 1 and class 2 here.
Yeah, on
Okay.
vacation.
They are on vacation. Okay, so the next one, I want to look at intervals too large to have length. Some intervals are too large. Class now. Or class now. So some intervals are too large to have length. So denote a point on the number line further to the right than any other point by this symbol. We call it infinity. So I have the number line. I have the number line. You always write this, we do this. We bring arrows, meaning that it is continuous. So I have 0 here. So the number that we cannot very far from to the right, here I write it negative infinity. And here I write it positive infinity. So when you take the far right, you have positive infinity. And that number is a very big number. And I take it far to the left, I have negative infinity. So it says that denote a number on the number line to the right than any other number we denote it by positive infinity. And point further left by this, we call it negative infinity. Now the symbol infinity depicts the never-ending nature of the extended real line. And when we take the real line, we have the following intervals. We have what we call closed left infinity interval, closed right infinity interval. And write it like this. When it's like this, then we say that x, so anytime you see square like this means that value there is part of the interval we are looking for. So this x such that s is greater or equal to a, but s is less than a, less than infinity. So this, and I have this closed, this one, it means that s is such that s is greater than or equal to a, but less than infinity. In other words, this can be written as x greater than or equal to a. Okay. So from basic school, if you have, or JHS or SHS, if you have 2 to infinity, or you normally write it as x greater than or equal to 2. So this thing is the same as s greater than or equal to 2. On the number line, if I have my 2 here, you remember that you choose your 2, you draw it with an arrow, and then because it is greater than or equal to, we're told that we have to shade. Do you remember this?
Yes, madam.
Yes,
Yes.
madam.
Yes, please.
So this symbol A closed to infinity or closed right interval is represented as this. In other case, so if I have open negative infinity and then A closed like this one is the same as x less than or equal to A, okay, or which is the same as x such that when I want to write it in the truth set, it's s such that my s is greater than or equal to, okay, so it's greater than infinity. Greater than infinity, but less than or equal to A. So on the number line, I can write this as, so I have 0 here, positive infinity, and then I have negative infinity somewhere. So it means that if this is my A, I have my A here, and the numbers less than A, they are here. And then because A is parts under this, I have to shade this. Okay. So we call this one closed right infinity interval. And what I just did, we call it closed left infinity interval. And then we also have open right infinity interval. So open right infinity interval, it means that okay. So open right infinity interval, I will not bring this. I will not bring the square brackets, but I will write open brackets. Okay. If it's open brackets, it means that from what I just told you, if it's open brackets, it means that my A is not part of it. It's not part of it. So if this is my A, then to draw this, I will just write that circle that I was taught. Then I will draw the straight line with the arrow. I will not shade because my A is not part. So this is X greater than A. Greater than A. We will not shade. Did you remember this problem? Do you remember that one too?
Yes, please.
Okay. So that is the open right infinity interval. Then we also have the open left. So the open left infinity will be negative infinity E like this. This is also equal to x such that I have negative infinity less than x less than A, which is the same as x less than A. So when I sketch on the number line, so this is 0. If I have A here, then, oh, sorry, this cannot be here. A cannot be here because if it's positive. So I have A here. Then to sketch it on the number line, I'll have this. Then go this way to infinity. I will not shade this because my A is not part. Okay, so that is the open left infinity interval. Okay. Note that a less than s less than infinity means x is greater than A. The whole number line is considered to be an interval expressed as from negative infinity to positive infinity. That is x such that x is less than negative infinity. Is greater than negative infinity but less than infinity. Okay, so example, want to solve the following inequalities and illustrate your answers on the number line. So want to solve this. To solve this from the theory, have two methods, either to square both sides or use the method where this value will lie between. So we can have So we want to solve absolute of x minus a, x minus 1, sorry. So we have absolute of x minus 1 less or equal to 2. Okay, so from the theory, we know that when you have something like this, it's the same as x minus 1 less than or equal to 2 greater than or equal to minus 2. It's like this. So we'll solve. So to solve this, I can add 1 across both because I have negative 1 here. So I add 1 on both sides. So I have minus 2 plus 1 less than x minus 1 plus 1 less than or equal to 2 plus 1. This will give me minus 1 less than, this one will give me x less than or equal to 3. So this means that my x is greater than negative 1, but less than or equal to 3. So when I want to write it in the interval form, I can write it as, because it is closed, I can write this one as negative 1, 3. So this is the same as this. Now, if I want to write it, represent it on the number line, I have my number line. So I have my number line. I have 0 here. I have negative 1 here. I have 3 here. Okay. So it says that my x is greater than greater or equal to negative 1. So I have negative 1 here. Greater than negative 1 is this way. But my s is less than or equal to 3. So my 3 is here. Less than 3 is here. So it means that this is what I'm looking for. But it's less than or equal to negative 1. So I have to shade this. And then it's greater than or equal to negative 1, and then less than or equal to 3. So I have to shade this. So this is the interval I'm looking for. Please, are you okay?
Yes, madam.
Yes, please.
So remember, you've seen this one somewhere. Those who did elective maths and others at the SHS, you did all these things. And maybe JHS too, you did it. Okay, so that is it. That's how to represent this on a number line. So we have another one. You will solve this one for me. Absolute of x minus 2 greater or equal to 4. Remember the theory is here. It says that if I have absolute of a greater than c, it is a greater than c or a less than negative c. So using this, I'm going to get a. So using that, you can use this here. It's going to be absolute of x minus 2 greater than or equal to 4, and then x minus 2 less than or equal to negative 4. Then use that to solve. So you have absolute of x minus 2, x minus 2 greater than or equal to 4. Then we're told that absolute of a greater than or equal to c will give me a greater than or equal to c, or a less than or equal to negative c. So please, using this theory, solve this one for me. Please solve this one for me. What will you get? Just find, first of all, find the values of x for me. Then we'll see how to represent it on a number line. Yeah, Abdul, what do you get?
Madam, I had x is greater than or equal to 6, and then x is
X is
less than
greater
or
than
equal
or equal to
to
S is
negative
less than
2.
S is less than or equal to -2.
Yes.
Okay, that's from Abdul. What did you also get? Any other alternative solution? Any other? Foster, what did you get? Foster, what did you get? John and Elizabeth, what did you also get? Elizabeth and Augustina. I'm waiting on.
Madam, please, I'm getting the same thing. No?
Oh, you got the same thing. Okay,
Yes,
John, what
please.
did you also get?
I got
Madam, please,
s
I
is
got
less than
I
or
got the
equals to
same thing.
6 and s is greater than or equals to -2.
Okay, thank you. Can we represent it on a number line?
Yes, please.
Okay, so represent it on a number line. Let's see what you get. Then when you finish, I'll also represent it on a number line. Okay, so you're going to get s greater than or equal to 6, and then less than or equal to -2. So you're going to write it as x such that s is less than or equal to -2 union s greater than or equal to 6. Or you can write it as interval. The interval notation will be the sets s in the sets -infinity, and then you have the -2 closed. Okay. Union, then you have the 6 and then positive infinity. So let's represent it on a number line. Okay, so we are getting something like this. X in the sets. Okay, so for this one, I have negative infinity and then -2. This is parts. Okay, union. Then this one I have 6 and positive infinity. Like this. So on the number line, I have 0 here. So I can have 6 here. So we are saying that we take 6 and then it is greater than or equal to 6. So I'll shade this. And then I have -2 here. So I take -2 and it is less than -2. So I go this way. But -2 is parts. Okay. So the interval is this part and then this part. But in between is not part of it. Are you okay?
Yes, madam.
Let's continue. Another one, we want to find the interval that satisfies the inequality 1 over 2x minus 1 greater than 1 over x minus 1. Okay. So to solve something like this, it's best to find,
Madam,
yeah,
please, can I see your number again?
my number line.
Yes, please.
This is my number line.
Okay. Okay, thank you.
You're welcome.
Yes, please.
Okay, so to solve something like this, we have to find LCM. But this one, because of the sign, we have to square the LCM, both of them. So the LCM, we have 2x minus 1 squared and then x minus 1 squared. Okay, so we multiply through by 2x minus 1 squared and then x minus 3 squared times 1 over 2x minus 1. And this 1 over x minus 1, then the 2x minus 1 squared and then x minus 1 squared. So after this, the rest is just simplification. That's what I taught how to simplify. Yeah, Foster, your hand is up.
Yes, ma. Mommy, please. Why do we multiply through by the square of the
Okay, so
denominator?
we multiply through by the square because it says that note that multiplying an inequality by a positive number does not change the direction of the inequality. And we know that if I square a number, it's going to be positive. If I have -2 and I square, it's going to be positive. So in order to maintain this, I will square it so that I'm going to get a positive number. Are you okay? Pastor, are you
Yes,
okay?
please. But madam, please. Oh, why did we multiply through by both the multiplications of the, how do you call it, the denominator squared? For example, we have 2x minus 1 all squared, x minus 3 all squared, multiplying the first section, that is the left hand side, and both the right hand side. If we are to eliminate by positivity, then why didn't we multiply the first one by the square root, the square of x minus 3, but instead both?
First, I'm coming. So we know
All right,
that
mommy.
1 over 2x minus 1, is it greater than or less than? It's greater than 1 over x minus 3. I know the LCM of this is 2x minus 1, x minus 3. I'm saying that because I don't want to change it, I will make it squared. So this will go into this.
Okay.
I'm going to have, this will go into this 2x minus 1 times x minus 3 squared greater than 2x minus 1 squared and then x minus 3. That's something like this. But remember, if instead of writing this, we can also, if I have 1 over a, maybe is equal to 1 over b. The LCM is a over a times b. So instead of dividing through like this, I can write ab and then times ab. Do you remember this?
Yes, mommy.
So instead of going through this stress, I decide to multiply through by the LCM to help me reduce my workload, because this one I have to simplify again, take my time to do everything. So multiplying through by that will help, and especially because of the sign, the best way to go about this is to multiply both sides by the LCM. I think there's a hand up. Daniel.
Please, so meaning if we are to change the sign, we can multiply it through by the denominators without squaring it.
Why do you want to change the sign?
Madam, I'm just asking.
Okay, so when you have something like this, the best way to solve it is to square the LCMs. How do you call it? Yeah. So that will help you to maintain the sign, but will not ask you to change the sign. So the best way to help you solve it is to maintain the sign. Then after that, if after the simplification, the sign will change, you will get it from there. There's no need to change the sign from the scratch. Richard, your hand was up.
Yes, madam, good morning.
Good morning.
Yeah, please, I beg you, I'm so confused a bit about the squaring. You know, the second example you gave, 1 over a less or greater than 1 over b.
Okay,
and
so
that one you
yeah.
didn't square it.
Oh, no. I
So
was
is it
just
in
giving,
all?
it's not an example. I was just explaining something. So because we want to maintain it, I was supposed to square both A and B because we want to square the sign. But I was just explaining to Foster that the LCM we can just multiply through by the. So sorry. So
Okay.
let me
So,
just
madam,
correct
please,
it.
you don't square it. Will it be wrong or it will be correct?
So you can for this example, you can decide not to square it and see what you get. It will lead you to a point where so the best way to solve something like this is to square it.
Okay.
Okay, so Rachel is
Thank you.
supposed to be like this. Yeah.
All right. Thank you.
Okay, so let's continue. So when we multiply through by this, as I said, this will cancel one of them. Those will cancel one of x minus 2 squared. So I'm going to get 2x minus 1, x minus 3. Is there a hand up? Richard.
It's a mistake.
Okay. So we simplify, you have 2x minus 1, x minus 3 all squared greater than 2x minus 1 squared, and then x minus 3. Then we can, when this one comes to this side, we're going to get 2x minus 1, x minus 3, minus 2x minus 1 squared, x minus 3, greater than 0. And then you can, whichever way you want to simplify it, you can simplify it anyway. But to me, I can see that I have x 2x minus 1 here, I have 2x minus 1 here. So it's a common factor. So I factorize 2x minus 1 out. Then for this one, I have x minus 3 squared. I have x minus 3. So I can see that x minus 3 is also a factor. So I factorize that one out. Then for this side, this one I'll be left with x minus 3. And this side I'll be left with 2x minus 1. Please, the simplification, that's why we're taught how to simplify. So whichever way you want to simplify is fine. But I think this one is simple for me. Okay, so simpler for me. But whichever way you can expand this. In fact, whatever you do, you're going to get something like this. So for mine, when I simplify this one, I have 2x minus 1, I have x minus 3. Then what is in the brackets, I have x minus 2x, which will give me minus x. Then I have minus 3 minus 1, which will give me minus 2. So you see that I have 2x minus 1, x minus 3, minus x minus 2, greater or equal to 0. This is the same as 2x minus 1. Because of the negative sign, I can let the negative multiply this. When it multiplies this, then this one will be positive. When it multiplies this, it will be x 3 minus x. And then this one will be x plus 2 greater than 0. And when you use another method, you are going to get a cubic function. And a cubic function, you have to find your factors. So it's the same thing. It says that sketching the graph of the polynomial function, which is a cubic function, the range of values of x for which the interval, for which the given inequality is satisfied is this. Okay, so for greater than 0, you have to look for values here. Values of x that when you substitute any here, it will be greater than 0. So you will see that when you choose -2 to infinity, from -2 to infinity, any number from -2 to infinity, when you substitute them here, it will be greater than 0. And then you will see that when you choose between half, 1/2, and then 3, and substitute them here too, it will also be greater than 0. So for the interval, you have to be smart and then try and choose values that will satisfy this. So the interval will be from -2 to infinity, and then half to to 3, sorry. So we can sketch this on a number line. Okay, but I think this would be a graph. But let's try and use just a number line to represent this. Okay. So I have this 0 here, maybe -2. So I have -2 to infinity. So -2 to infinity. This is more parts. And then from half, so maybe I have half here. Then I have 3 here. So between half and 32, it is there. So I have something like this. And this one. So this side, this one is satisfied. Okay. And then I'll have from this side too. Okay. Or you can, on the number line, you can draw it like this. If you want to use the number line that we used. If I want to use the graph, then I'll have half and 3, and then -2. Okay, so maybe it will move like this. This is a quadratic curve, so something like cubic curve. So this is part of it, and then this also part of this. So when you sketch it, I don't know, maybe when I sketch it, either it will go up or down, but it should be something like this. It's either like this or the opposite, but the interval is this side and this side. Okay. So I think when we get to graph of quadratic function, then we'll be able to maybe draw it well if it's going to be something like this. Then we sketch it. Okay, so there's a hand up. Joshua, your hand is up.
Yes, madam. Madam, please. I want to know the reason why we have to square the denominators before we multiply through. Hello, madam.
Hey, Joshua, were you in class? Because I think somebody asked, Foster asked, I explained, and it's even on the board. It's
Please,
even the note.
the network is my network, guys.
Okay. So please, it's here. Note that multiplying an inequality. So there's an inequality. And multiplying an inequality, we don't know. Maybe when we multiply it through by the LCM itself, it can change the solution. So the best way to solve an inequality like this, 1 over something, the best way is to multiply through by a positive number. And the positive, we know that any number squared is a positive number. So we'll just multiply, we'll square the LCMs and then multiply through. So it says a note that multiplying an inequality by a positive number. The positive number, we are seeing it as the square. It does not change the direction of the inequality. So that's the reason why we are squaring. Okay. Are you okay, Joshua? Hello, Joshua. Okay, so we have other examples here. So please try and then try your hands on them. Okay, so I want to continue. So the next thing we want to look at, we have linear and quadratic functions. Okay. So when we talk about linear function, I hope you know linear functions. So as I said, we are still revising. A linear function of x is defined by this, maybe skinny or something. Is defined by this, f such that s is equal to ms plus c. You've seen this one before, right? Have you seen this one before?
Yes, madam. Yes, madam.
And what is that? What is that? What is ms plus? You said you've seen it. What's
Why?
Equation of the line.
equation of
Equation of a line.
Equation of a straight line.
Gradients, equation of a line.
equation of a line.
Mm-hmm.
A line is a linear function. Straight line is a linear function.
Yes.
So the
Yes, please.
expression is given as ms plus c, and your m is your gradient, and your c is your y-intercepts.
Intercept.
Now we look at some characteristics of a linear function. So if the function is f of s, therefore f of s has non-vertical straight line graph. So it's supposed to be a non-vertical straight line graph. And then let a given value of the linear function be y1 is equal to f of x1 at s is equal to x1. Then my f of s is given as f of s is equal to m into bracket x minus x1 plus y1. Okay, so we know this. If we use y minus y1 is equal to m into x minus x1, then the equation is given as this. Okay, so let's look at this characteristic. It says that if my gradient is greater than 0 and my x1 is less than x2, it means that my f of x1 is less than f of x2. Then the graph is referred to as an increasing function. And when I give this, then you should be able to sketch it. You should be able to sketch this and see if it is truly an increasing function. Okay, so that's what we are saying. We are saying that if my x1 is less than x2 and my f of x1 is less than f of x2, so this the points x1 f of x1, x2 f of x2. When I draw the graph, it's going to be something like this. It says that this has a positive gradient. So my m is greater than 0. When you have something like this, you call it an increasing function. The function is increasing. Now the other one, if I have x1 here, I have x2 here. If my x1 is less than x2, but my f of x1, so if I have f of x1 here, and then I have f of x2 here, then this we can see that it is descending. So, and then this one will have the gradient less than 0. So this is a decreasing function. This is a decreasing function. Please excuse me.
Hello.
Hi. The network.
No, she's muted.
Yeah,
Oh,
madam. Madam, please check your mic. Oh.
No, she
Yeah, she said
said we should
she's coming. She said she's coming, so she will join us soon.
Okay, okay. Thank you.
So
Oh,
what are
okay.
the some of you in
Hello,
this?
please, I'm here. Please, I'm here. Please, I'm here. Please, I'm here.
Madam, welcome.
Thank you. Okay, so I said that if m is less than 0 and x1 is less than x2 and my f of x1 is greater than f of x2, then the function is a decreasing function. And I think I have the graph here. I have x1 less than x2, but my f of x1 greater than f of x2, and my m is less than 0.
Madam, please,
So
your
this,
screen is not showing.
It's showing, you know.
it might be
so
the
please
network.
check your network. So this is a decreasing function and this is an increasing function. So if I call this one graph B and then I call the other one graph A, my graph A is an increasing function. My graph B is a decreasing function. And then the last one, this I have x1 less than x2. But if f of x1 is equal to f of x2, so they are the same. This is a constant function. Okay. And then my gradient will be 0. Okay, so when you check, the gradient here will be 0. Here the gradient will be 0. So if my gradient is 0, so this is the fifth one. If m is equal to 0, x1 is less than s2, but f of x1 is equal to f of x2, then the function is said to be a constant function. Okay, so we can have the graph here. This is increasing, this is a decreasing function. Everything combined, we have a decreasing function, a constant function, and an increasing function.
Okay.
Okay, so once you look at some remarks, let L1 and L2 be graphs of functions f of x and g of x respectively with gradients m1 and m2. We know when we say two lines are parallel. If L1 and L2 are parallel, then it means that my gradients are the same. So M1 is equal to M2. And then if L1 and L2, I mean the two lines, if they are perpendicular, then it means that the product of their gradients is equal to -1. And then the third one says that a non-constant linear function defines a one-to-one mapping in the set of real numbers. So last time we defined what a one-to-one function is. So looking at my graph, we are saying that whether it's increasing or decreasing, it's a one-to-one. So with the graph, I'll just draw a horizontal line. You see that it touches it at only one point. So this is a one-to-one function. And then when we take the positive 1, 2, we draw a line and it will touch it at only one point. So it's true that a non-constant linear function defines a one-to-one mapping in the set of R. Example says I find the equation of the line that is parallel to the line y is equal to 2x plus 1 and passes through the point 5, 4. Okay, so we know that to find the equation of a line, we need the gradient, but we are told that the line that we are looking for is parallel to the line y is equal to 2x plus 1. Now, when I pick y is equal to 2x plus 1, we know it's the same as, we can write it as ms plus c. So my m here is 2. So the gradient for this line is 2. But we are told that the line we are looking for is parallel to this. So they are supposed to have the same gradients. So it means that it says that the slope of 2y plus 1 is 2. And the parallel line needs to have the same gradient or slope. So the slope of this line, the line with this point, is also 2. So the equation will be y minus y1 is equal to 2 into x minus x1. So I have y minus 4, my y is 4. Y minus 4 is equal to 2 into x minus 5. Then when I simplify, I'm going to get my y to be 2x minus 6. So that's the line we are looking for. Another one says that given that sine 11 is equal to 0.1908 and sine 12 is equal to 0.2079, sine 13 is 0.225. We want to find a linear approximation for sine 11.3 and then sine 12.6. Okay. So we are given sine 11. Sine 11 is this. Sine 12 is this. So sine 11.3 will lie between, we know that the value, this is my S value, we need you. My S values lies, the 11.3 lies between 11 and 12. So f of s is equal to sine s, and it means that my s values, I can have 11, and then the y value is 0.19. So please, I'm using this. That's my s value. The 11 is my s value, and the value here is my y value. This is my s value, and this is my y value. This is my x, 13 is my x, and this is my y. So it means that when I pick 11, the corresponding y value is this. When I pick 12, the corresponding y value is this. Okay. So I have 11 with the y value, 12 with its y value. So I want to find the gradient. We know that the gradient is y2 minus y1 divided by x2 minus x1. So the gradient, I'm going to get 0.017 this. So that's my gradient. Okay. So to find the equation, I know I have sine x is equal to my gradients into, so I'm using any of the points. To find the equation, you can use this point or use this point. So I have sine x is equal to the gradient that I have found into x minus 11. I'm using the first one plus its corresponding y value. When I simplify, I'm going to get sine s is equal to 0.0171 x plus 0.0027. This is the expression for my sine x, but I want to find sine 13. So sorry, sine 11.3. So this one, I have the s value to be 11.3. So x is 11.3. In place of this x, I will substitute 11.3. So sine 11.3 will give me this times the 11.3 and everything. When I simplify, I'm going to get 0.19593. And what I have done here, we call it a linear interpolation. Okay, so you can solve it for sine 11, sine 12.82. So sine 12.8, you just substitute 12.8 in here, and you get the value. Okay, so we call it linear interpolation. Any question? I want to continue with quadratic functions. So we know characteristics of a polynomial function and others, and how to even find an equation of a quadratic curve, a linear curve, sorry. So, Gifty.
Okay, madam, please, this one that we calculated right now, finding sine 11.3. Is it possible that you can, yeah, you can find sine 3, sine 0.3 and add it to sine 11 and get the correct answer, like in objectives?
Thank you very much, Gifty. Please, Gifty, the question says that you should find a linear approximation. So to find a linear approximation, we want you to get an equation. So he wants you to get an equation, then after that you solve. And anytime you are given expression of values in a question, you have to make use of them. If not all, you have to make use of some of them. So the best way, you find sine 0.3, no, please, you cannot do that. You can even just point sine 11.3 on your calculator and you get the answer. But here you are to apply what you have learned. So you have to get a linear equation, and to get that you have to find your gradients, and then you use the point to get the solution. So that's what we want you to apply here. Objective, no, I don't think something like this. Okay, I don't know, but when you point your calculator, you're going to get the answer that we've gotten here. But assume you don't have a calculator and you have this point. Okay. So I want you to make use of the thing you just learned. Are you okay, Gifty?
Yes, madam.
I want you to get a linear approximation, a linear function, and then you use it to solve. You solve sine 11.3, sine 12.6. So to find that sine 12, you can also use these 2 points, the 12 and 13, to get an expression. Then since 12.6 lies between this, you can substitute the value. You're going to get the same answer. You're going to get the answer. Okay, any other question? I want to continue with quadratic functions. Can I continue?
Yes, madam.
Yes,
Please, you
madam.
Okay, so we are
Yes,
continuing.
please.
We want to look at quadratic functions, and quadratic functions are given as ax squared plus bx plus c, where my a is not equal to 0, and my a, b, c are constants. So we know that anytime you have f of x is equal to ax squared plus bx plus c, we call it a quadratic function. Let a, b, c be real numbers with a not equal to 0, then the function given as this is called a quadratic function. Now we want to look at the graph of a quadratic function. Anytime, all the time when we sketch the graph of a quadratic function, it looks like a U. So whether it's a U or it's a U turned upside down. Okay. So the graph of a quadratic function is a special type of U-shaped curve called a parabola. Okay. So parabolas occur in many real life applications, especially those involving reflexive properties. So I know all of us, or most of us, have the, how do you call it, multi-TV dish. And when you take it, you see that it's a U-shaped. So the satellite dish is an example of a parabola. And then when you pick your flashlight and your torchlight, you see that it is also, when you pick your torchlight, you see that it is a parabola in shape. And then even the car lights, you see that it has parabola shaped in it. Okay. Then all parabolas are symmetric with respect to a line called the axis of symmetry, or simply the axis of the parabola. So when you pick a parabola, so what I'm talking about is, I'm saying that when you pick a parabola, it's always like this. The graph of a parabola always look like this. Then you have a line that divides it. Okay. And this line, we call it the axis of symmetry. Then the point where the axis intersects the parabola is called the vertex of the parabola. Okay, so those points, we call it the vertex, this point. want to look at standard form of a quadratic function. The quadratic function is given as, okay, so the standard form, in the standard form, we'll write the quadratic function as a into bracket x minus p squared plus q, where my a is not equal to 0. So anytime you see it like this, we call it the standard form. The graph of f is a parabola whose axis is the vertical line s is equal to p and whose vertex is the point pq. Okay, so when you have it like this, the vertex is given as p comma q. Now, when you have a parabola with a, so if my a is negative, it's greater than 0. If my a is greater than 0, it means that the parabola opens upwards. Well, what I mean by upwards, it's like this. It opens like this. So if my a is greater than 0, then the graph will look like this. If my a is less than 0, then the graph will look like this. Okay. Now, if it looks like this, then it means that I have a minimum turning point. If it looks like this, then it means I have maximum turning point. So if my a is less than 0, then I'm going to get a maximum turning point. If my a is greater than 0, then I'm going to get a minimum turning point. And this one opens upwards, this one opens downwards. So the standard form is like this, as I mentioned. Okay, so it says that identify the vertex of a quadratic. So first, we have a question. We want to describe the graph of this function and identify the vectors. So this graph, looking at this, what is my a?
A is 2.
Is 2. Is it positive or negative?
Positive.
Positive. So the graph, is it going to open downwards or upwards?
Upward.
Upwards.
Okay, so it's upwards. So it means that I'm going to get a minimum turning point, right?
Yes, please.
Actually,
Because a is greater than 0.
Okay. So we want to write it in the standard form. A into bracket x minus p squared plus q. So writing the quadratic in standard form by completing the squares. So if have you heard of completing of squares before?
Yes, please.
Yes, madam.
So I won't say that. Please forgive me, I'm lying. Okay, recall that the first step is to factorize out any coefficients of s squared. That is not 1. So the first method in the completing of squares, you have 2s squared plus 8s plus 7. You can decide to have the one with the x in the bracket. So you have 2s squared plus 8x in a bracket plus 7. Then you factorize the 2 out. So you have 2. Then this one will be left with s squared plus. And then when this one 2 comes out, it will be left with 4x. So I have 4x plus 7. Okay, so repetition 2 into bracket s squared plus 4x plus 7. And then to the completing of square, what we do is we divide the coefficient of x by 2. We divide, so the coefficient of x for this is 4. We divide this one by 2, going to get 2. We square the 2. So we square the 2, we add, and then we subtract. So we add and subtract the 2 squared, meaning I've not done anything to the question. So I divide this one by 2, I'm going to get 2. I square the 2, which is 4. So I add 4, I subtract 4. So this one, when I simplify this, it's the same as s squared plus 4x, because this and this will go away. It will take, this one going to be 0. Please let me take my time and do it, because there are some jumps here. I'm sure my cousin may read note to my mama. Okay, so let's start. We have y. So I have y is equal to 2x plus square plus 8x plus 7. So that's what I do. I'll write this as 2x squared plus 8x in a bracket plus 7. Then I factorize 2 out, 2 into x squared plus 4x plus 7. So it's the same thing. I've not done anything. Now I want to start with the completing of squares. So I still have my 2. I have x squared and then plus 4x. I will divide this one by 2. So I'll add and subtract. So I have plus, this one divided by 2 is 2. So 2 squared. Then I'll subtract. So I'll subtract 2 squared, 2. Then plus 7. So this is 2 outside, x squared plus 4x plus 4 minus 4, and then plus 7. I want this one to go out. So this is 2 into x squared plus 4x plus 4. This one times 2 will give me minus 8. So minus 8 plus 7. So this is 2 into x squared plus 4x plus 4 minus 1, like this. And then I can write this one as a plus b all squared. So writing this one as a plus b all squared, this is 2 into x plus 2 squared. I hope you can expand this one. This one will give me x squared, 4x squared plus 4. So the whole of this thing here is the same as x plus 2 squared. Then all minus 1. I've written this one in the standard form. The standard form is a into x minus p squared plus q. So I've written this one in the standard form. So in the standard form here, my p is, what is my p?
2.
The p is 2, positive 2.
Are you sure it's 2?
Minus 2.
P is minus 2. And what about my q? What about my q? Minus 1. Okay, so we are told that the vertex is PQ. So it means that it is minus 2, minus 1, like this. Okay, so it means that from the standard form, the graph of S is a parabola that opens upwards, as you told me, with vectors -2, -1. So if I want to compare it with the equation y is equal to 2x squared, it says that this corresponds to a left shift of 2 units and upward shift of 1 unit relative to this graph. Okay. So let me just try and sketch this graph for you. The graph with vectors -2, -1. Okay, so I have my XY plane. Then I have -2 here, and maybe I have -1 here. Okay, so we are told that it has vectors -2, -1. Vectors is the same as the turning point. So this graph will look like this. I didn't sketch it well, not done to scale, but it will have turning points like this. This is supposed to be round. It's not a sharp curve. So it's supposed to be something like this. The graph will look like this.
This one is resemble something.
I think with him,
It resembles something.
Okay, so this is the graph. Now, from the explanation, it says that when I compare it with the graph, so this is the graph of y is equal to 2x squared plus, is it 8x plus, is it plus 7 or minus 7? Plus 7. And then when we put it in there, we have something like x plus 2 squared minus 1. So this is the same as this. Okay, so if I want to compare this one with the graph y is equal to 2x squared, we can see that for the x part, I've added 2. So you've seen that it is, I've added 2 to this, so, and then I've subtracted 1. So this means that when I look at this graph, we'll get to translation. The graph y is equal to, this is the graph of y is equal to 2x squared. Now, when I compare these two, you see that this graph, it looks like this, but it has shifted 2 units. It's supposed to be at 0, but now it's -2. So it has shifted 2 units to the right. And then this original one is at 0, 0. But this one, it has come down. So it means that it has shifted 2 units to the right and then 1 unit downwards. So that's what we are describing here. It says that this corresponds to a left shift of 2 units and a downshift of 1 unit relative to the graph y is equal to 2x. Al-Hassan.
Madam, please, is it 2 units to the left or to the right?
It's to the left, please.
Thank you.
So looking at the graph, it's to the right. So please, this is to the left.
All right.
Okay, let's continue. Catch an message down.
Yeah, hello, madam.
Yes.
Hello, madam.
So this is the, yes, dear.
Please.
I'm listening.
That the -2 is a minimum value.
What?
I'm asking, in case you are asked to determine the minimum value.
The minimum value is the y value. So the minimum value is -1. Minimum value is the f value. Y value, f of s value. So it is -1. The minimum value, we are talking about the f of x value, and it is to the y. So the minimum value is f of -2 is equal to -1. So minimum value is -1, not -2. But the axis of symmetry, that is -2. So you draw the line, please, not drawn to scale. So that's my -2. So the axis of symmetry is the line s is equal to -2. Our minimum value is -1.
Okay, thank you.
Welcome. So we have another one. We want to describe the graph of f of s is equal to -s squared plus 6s minus 8. And we identify the x-intercepts. Okay. So we're using the quadratic and completing of square. But looking at this, how will the opening be? Is it upwards or downwards?
Downwards.
Downwards. So it means that are we going to get a minimum value or a maximum value?
Upwards.
Maximum value.
Maximum.
We're going to, okay.
You get a maximum value.
Okay, thank you very much. So using the completing of squares, I can write this one as -s squared plus 6s minus 8. Then I can bring -1 outside. So I have s squared minus 6 minus 8. Okay. Then I have to divide this one by 2. Dividing this one by 2 is 3. So I square the 3, I add and subtract. So I'm going to get x squared minus 6x plus 9. So 3 squared is 9, then minus 9. Then you close the bracket, minus 8. So this is the same as that. And then I'm going to get x squared minus 6x plus 9. Then this 9 will move to this side. I already have negative, so negative will be positive 9. So positive 9 minus 8 will give me plus 1. Then x squared minus 6x plus 9 can be written as x minus 3 all squared. Yeah, 2 hands, Gifty, and then Isa. Isa, please. Isa first. Isa, your hand is up.
It's now confused.
It's what?
The 9, the x square minus 6x plus 9 minus 9. That's where I am confused.
So I have y is equal to minus x squared plus 6x minus 8. So this is the same as minus x squared plus 6x minus 8. This is the same as minus 1 into bracket x squared minus 6x minus 8. So minus 1 into x squared. I said that you have to divide the 6 by 2. So minus 6x. When I divide the 6 by 2, it's going to be 3. So the 3 that I will get, I'll square the 3. So I square the 3, which will give me 9. Then I'll add the squared to the function, and then I'll also subtract. So when I add a number and then I subtract the same number, it means that I've done nothing to the function. So I have 6x plus 3 squared minus 3
Well, well
squared.
noted. Well noted.
Okay. Minus 6x plus
Allow him
9
to compute it. Okay.
plus 9 minus 8, like this. So it's minus 9, but because I'm multiplying by negative 1, that's why it is positive 9 here. So this minus 1 into. So this thing here can be written as x squared minus 8, sorry. It can be written as x minus 3 all squared. Then this minus this will give me plus 1. Are you okay?
Yes, madam.
So here my a is minus 1, a is minus 1. Then getting the p comma q, comparing my p is, what is my p? Comparing it with a into x minus p q. So my p is 3, and then my q is 1.
P is 3.
Okay. So we can sketch this.
Please, the P is negative 3.
So the standard form is x into bracket, a into brackets, x minus p. So it's supposed to be minus. So my p is positive 3. Okay, so when I sketch it like this, I have 3 here, and then positive 1, maybe 1 here. So 3, 1 is here. And then I know that it's supposed to open downwards. So I have something like this thing there. So maybe there is something like this. Okay, so my axis of symmetry is this. So is the line S equal to 3. And then the maximum point, as you know, is this. So maximum point is that y is equal to 1. Okay, so if I want to compare it with the graph of y is equal to minus s squared, then it corresponds to the graph of minus s squared, which has been shifted 3 units to the right and 1 unit upwards. Please, can you see it?
Yes, please.
So the graph of this is like this. This is the graph of y is equal to s squared. Now it has been shifted 3 units to the right and 1 unit up. Invigilation. Please excuse me. And now when to me and Freddie, yeah, mommy. Hello, please. Can you continue?
Yes, please, madam. We can continue.
Give your hand is up.
Okay, madam. Okay, my question is, in using the completing of squares, when the coefficient of s squared is greater than 0, like say 2 or 1 or 3, you take it, you factorize it out and divide it through by the other numbers. For instance, for the first one that we did, the example that we did, we had 2s squared plus 8 squared plus 7. So you factorize the 2 out and then you divide it by the other numbers. So we are going to have s squared plus 8x plus 7 divided by 2, but I didn't see that one there.
Yes, Madam Gifty. Madam Gifty, please, I wrote it as...
What I learned is not the correct one. I just want to...
Okay, so Madam Gifty, I wrote mine as 2s squared plus 8s in a bracket plus 7. So it means that whatever I'm going to do, I will not touch my 7. So I brought my 2 out, then I have s squared plus 4s in a bracket plus 7. So I will not divide through by the 7 because I didn't add the 7 to the brackets. If
you put it in the bracket, meaning you're not going to check the constants.
So if you decide to add the 7, then it means I have to remove this brackets and then bring the brackets here so that this will be 7 over 2. Then later, when I get here, it's still 7 over 2. So when I multiply through by 2, my 2 will still vanish, then I'll still have the 7. Are you okay?
Yes, madam.
So what you did, what you know is correct. But mathematics, you can adopt any step. You can decide to let the 7 stand untouched, then you open the brackets for only the 2. It's the same thing. You're going to get the same solution.
Thank you, madam.
You're welcome. Okay, so I think the right thing to do is to understand the concepts. So when you understand the concept, you understand mathematics, then you will know whatever you want to do. So you know that you open a bracket, then you have this. This is how it's going to be. If you include it, this is how you're going to do. So it's the understanding of the concepts of mathematics, okay, and the theories. Thank you very much. Please, can I continue?
Yes, please.
Okay. So it says that the graph of f is a parabola that opens downwards with vertex 3, 1. the s-intercept. Okay, so I think the question were to determine something. It says that and identify any intercepts. Okay, so finding and determine any intercept, it means that we have to go extra mile to solve. So I have to solve
Any
this
X,
quadratic
any X.
x-intercept. Okay, so we know that at the s-intercept, y is equal to 0. Equanim, please come. Please excuse me.
With Nkunim on our side, we shall surely pass.
Oh, you can actually win.
Amen. But we will come and borrow
Nice of
Nkunim so that Nkunim will go with us.
Okay, so let's continue. So to find the intercept, the function is negative x squared plus 6x plus 8. Is it plus 8 or minus 8?
Plus 8.
That's it.
Hey, sorry,
Which
minus
one
8.
was minus 8? Minus 8 equal to 0. So we know that to find the x-intercept, we have to solve this. So to solve this, we can divide through by -1, which is x squared minus 6s plus 8 equal to 0. Then you have to find the factors. Two factors that when you multiply, you're going to get 8. Then you add, you're going to get 6. So we have x squared minus 4x plus 2x plus 8. Is it minus? It's supposed to be minus 2. This equal to 0. So I can write it as x minus 4 minus 2 into x minus 4 is equal to 0. So I'm going to get x minus 4 and then x minus 2 equal to 0. So my intercepts are, my s-intercept, it means that my y values are 0. So my intercepts are 2, 0, and then 4, 0. These are my intercepts. So to sketch this graph there, to sketch this, I know that I have two intercepts, 2, 0, and then 4, 0. And then my vertices, the vertex 2 is what? What did we get? Is it 3, 1? We had 3, 1, right? So 1 is somewhere here.
Yes, madam.
So 3 is, I have 3, 1. So it means that the graph will look like this. And then the axis of symmetry is this. This is S is equal to 3. So this is the graph. Okay, so let's continue. It's not easy life. Let's continue.
Yeah, blue.
I'm enjoying the feedback.
Yeah, na yebre.
Really, every. But madam, madam is in heaven.
It shall be well. It shall be well.
Okay, so we are continuing writing the equation of a parabola. So still on the quadratic curve, it says that write the standard form of the equation of a parabola whose vectors is 1, 2, and that passes through the points 3, -6. So we know our P and Q. Because the values of the graph is P and Q, but here we are using H. It's the same thing. So please don't get confused. Either PQ is the same thing. It's 1, 2. So in the standard form, I'm going to write my f of x to be a into brackets x minus my p value, which is 1, plus all squared plus my q value, which is 2. So in the standard form is this. But we are in Shakam for A. We are told that it passes through this point. Passing through this point will help us to get our value for x and y. Okay, because the parabola passes through the point A. This thing is not charging. It is not charging. It's not charging. Why is it not charging? Sorry. Please, sorry. All this while my laptop was not charging. So it's about to. Okay. So because the parabola passes through the point 2, 3, it follows that my f of 3 is 6. So this will help us to get the value of A. Okay. So I have f of x, which is 6 is equal to A into brackets, and then my x value is 3. So 3 minus 1 squared plus 2. So this one will give me 2. 2 squared is 4. So I have minus 6 is equal to 4A plus 2. Then this minus 8 is equal to 4A. So my A is minus 2. So when I write it, I have minus 2 into brackets x minus 1 squared plus 2. And you should be able to describe this graph. Is it going to open upwards or downwards?
Downwards.
It's going to open down. Okay, so it's going to open downwards with a maximum value. So open downwards means that we're going to get a maximum value. So the maximum value is what? What's my maximum value? Ademayoku.
Yeah, madam.
The maximum value is
Madam, the maximum value is 2.
The network.
2. Thank you. The maximum value is 2. Thank you very much. So my maximum value is 2. And then the axis of symmetry is what?
1.
Is the line x is equal to 1. It's not
Like
just
6 and
it's x equal to 1. So this is it. It opens downwards. The maximum value is at 2, and then the axis of symmetry is 1. So this is how to find the minimum and then maximum value. You see, many applications. Many applications involve finding the maximum or minimum values of a quadratic function. By completing the squares of the quadratic function, going to this, you will get something like a into s plus b over 2a squared plus c minus b squared over 4a. So if it's like this, then the vectors of the graph will be minus b over 2a, and then f of minus b over 2a, or c minus b squared over 4a. Okay. So consider the graph this with vectors this. If my a is greater than 0, then f has a minimum value at s equal to minus b over 2a. And the minimum value will occur at f of minus b over 2a. Then if my a is less than 0, then f has a maximum value of b minus b over 2a, and then the maximum value occurs at those points. Okay, so example, it says that the path of a baseball is given by the function f of s is equal to negative 0.00232 s squared plus s plus 3, where f of s is the height of the baseball in feet, and s is the horizontal distance from home plate in feet. What is the maximum height reached by the baseball? Okay. So to do this, we have to solve. Okay. So this is the quadratic equation. F of s is equal to a squared plus bs plus c. So here my a is negative 0.0032. Okay. My b is 1, and then my c is 3. So it says that because the function has the maximum value, because we know that it is negative this, so it means that the value will be minus b over 2a. Okay, so my b is 1, so I have 1 over 2, and then my a is this value. Okay, so when you solve, you're going to get your x to be 156.25 feet. So that is the s value. Okay, and then we have to find, it says that we should do what? What is the maximum height reached? So the maximum height, it means I want to find f of 156.26. So in place of x in the equation, I'll substitute this value. And when you substitute, you're going to get 81.125. So that is the maximum value. And then my S value is this.
And I make it well.
Please, after the class, take your time and read the notes. Learn the notes. Now we have methods of solving quadratic equations. So we can use the quadratic formula. I hope you all know that is what you call almighty formula. You can also use factorization. So you factorize. You can also use the completing of squares that we just used, and then also factor by grouping. Then characteristics of the quadratic function.
Please, madam, your screen is not showing.
It's coming from your end, please. Check from your end. So by translation principle, if I have f of x is equal to ax squared is equal to bs plus c, then the graph is the image of the parabola y is equal to ax squared under a suitable translation, like what I did. So you see that each of them, I'll compare it with f of x is equal to ax squared. Then we know whether it is shifting to the left or to the right, whether up or down. So that's what we are talking about. Then by completing square completion, we do this. So if I have y is equal to ax squared plus b s plus c, then what our sister asked, I decided to factorize the a out. Then I will include the c in the bracket. So I have a outside x squared plus b over as plus c over a. Because the bracket covers the c, that's why I'm dividing through by the c by the a. Okay. So after this, I have to find half of my b over c, my b over a, and half of b over a is b over 2a. So as we're doing, we'll add the square of it, then we'll subtract the square, then plus my c over a. Then when I simplify, I can see that from s squared plus b over as plus b over 2a squared can be written as x plus b over 2a squared. Then when I simplify this, b minus b over 2a squared plus c over a, I can, when I simplify it, I'm going to get 4ac minus b squared over 4a squared. I think there is a hand.
Madam. Hello, madam.
And
Question. Out of curiosity. So let's say if
excuse
we
me,
are to write,
excuse me.
okay.
Hello.
Hello, madam.
Hello.
So let's say
Madam is coming, please wait.
where?
Why?
John A, please. I hope you understand everything now. You teach me.
Yeah, my bread.
It's Christy.
Christy, absolutely need a Mahira. Absolutely already a Mahira.
It's not easy.
Boss man. Yeah, my bread.
Mr. Samuel Boatin, Patrick chatting here. I beg, it's emergency. Mr. Boatin.
Emergency Benny.
Please, I'm back.
Okay.
Welcome.
Alasa, please, I'm here. Ask your question.
Yeah, madam.
Thank you.
My question is out of curiosity. So let's say if we are to write the exams, would they provide us with their formulas?
Formula form.
My
goodness.
You provided the formula.
One thing is,
There's no formula. What formula are you talking about?
You are no formula. It's a concept.
Please switch formula.
Almighty formula.
I know that you approve by you. Almighty formula.
We are building the concept. We are not providing any formula.
We've gotten A is equal to this. A, Y is equal to
This is almighty formula.
Okay.
Almighty.
So please let's continue to prove the quadratic formula. So
Okay,
we have
madam,
y
thank
is
you.
equal to A. Okay, welcome. You have y is equal to A into, I told you that x squared plus b over ax plus b over 2a squared, this one squared, is the same as x plus b over 2a all squared. When simplify, you b squared of 4a. We were taught how to simplify. You see expanded. So I know that since
Madam, the screen is awful.
You were expert.
The line is breaking.
The line is also breaking, madam.
The screen, it has come.
Okay. So
It's in
as
the
I was
it's in the
said that since we
We can hear
since you
anything.
passed BEC and you need to go to the
screen.
Can you please shift, position yourself for, I think the network is breaking.
The screen. It's your beautiful picture which is there.
That's all right.
Dominic, will you?
But that picture too is a nice power.
Okay.
No, I was only saying what I'm seeing.
Please.
Guys, let's forget not that.
Guys, I
Let's forget
even
not that.
I didn't get some.
Please, everyone, why you na? Enkoyo.
Any yeah blue. Yeah blue.
Yes, you won't. I don't know. You could say, Madam Wabutan.
Yeah blue.
Please, I'm back.
Righteous.
Boss man.
Please, I'm back.
All right.
Okay, so So I said that you were to pass your BC, and I remember in the BC mostly give you.
I want to hear this one on this motivation. I want to hear about that.
Did your WASI or SSC, and that one too I know you passed. That's why you are here. And remember those ones too, you were getting expand and simplify. So now you are expert in expanding and simplifying questions. Okay. So here we will expand and simplify this and get 4ac minus b squared over 4. Okay. So multiply through by a, I'm going to one times a will cancel one of the a's. So I'm going to get 4ac minus b squared over 4a. Michael.
Yes, madam. Madam. Yeah. For this concept, the LE, I saw the a x square plus, but are we dividing through by the a to get rid of a, or we are factorizing the a out?
We are factorizing a out. So because this one does not have a, this one does not have a. When I factorize a out, I have to divide through so that when it goes, when I'm open the bracket, it can cancel the a's and then get the original function.
Oh, okay, thank you, madam.
Okay, so we've gotten y is equal to a into x plus b over 2a squared plus 4ac minus b squared over 4a. And when we compare this one with the standard form, my p is a. So that's what I have. Okay, so the equation will be written as p minus q is equal to a into brackets s minus p squared. And this form, the graph of f of s is the image of the graph of. Okay, so still, if I compare it with y is equal to as squared, then we can see that by translation, we have the point PQ as this. So my P is this, and then my Q is this. We are not. Now, if I want to find the zeros or the roots or the x-intercepts, it means that my y should go to 0. My y-intercept, my x-intercept, y should go to 0. But let's continue. I think we have to look at the turning point of the graph first. It says that if a is greater than 0, then we know that we're going to get a minimum turning point. So the point PQ is a minimum turning point of the curve. Thus f of s has a minimum value of q, which is 4ac minus b squared over 2a. Or at the point s equal to p, or f of my p, which is f of minus b over 2a. Now, if a is less than 0, we know that we have a maximum turning point, and the value is 4ac minus b squared over 4a, and it occurs at s is equal to minus b over 2a. We say the expression s is equal to minus b over 2a represents the line of symmetry of the curve. So from what we've done so far. Okay, so if it's greater than 0, we have a minimum turning point. If it's less than 0, then we have a maximum turning point. We have the graph f of s is equal to a squared. Okay. And we know that if a is greater than 0, then we have minimum, so it opens up. A greater than 0, it opens downwards. Okay, now, so I was talking about the zeros of the function. So the zeros are the values of s at which f of s equals to 0. Okay, so to find the 0, we equate we let our f of s or our y be equal to 0. So the zeros is the same as the x-intercept or the how do you call it? Okay, so the zeros or the s-intercept. There's another one I've forgotten. Okay, so it means that my y.
Can you say the root? The zeros or the
The
root?
root, okay. Yeah, it's the same as the root. So the zero, the root, or the intercept, y, s-intercept. Okay, so this is equal to 0. Y is equal to 0. So I have ax plus b over a into bracket s plus b over 2a, the squared plus 4ac minus b squared over 4a equal to 0. So I simplify, as I said, you are expert in simplifying. So this one comes to the other side, then I have a into bracket s plus b over 2a, or in a bracket squared is equal for a. So simplifying, I divide it by a, so I'm going to get s plus b over 2a, all squared is equal to b squared minus 4ac divided by 4a squared. Then I find square roots on both sides. So square roots will take care of the square here. So I have x plus b over 2a is equal to, I know that square root is going to be plus or minus. So plus or minus square root of b squared minus 4ac divided by 2. Okay, so divided by square root of 4a squared is the same as 2a. Square root of 4a squared is 2a. Okay, so I make s the subject. So my x will be minus b over 2a plus or minus square root of b squared minus 4a divided by 2a, which is the same as minus b over 2, minus b plus or minus square root of b squared minus 4a divided by 2a. So the zeros, I can have one of them will be positive, so I'll consider the b squared plus the what's the standard, the radical sign divided by 2. Then I have b squared minus. So the zeros are this and this. Okay, so these are the zeros, and we can also call them the roots of the function. And this is what we call the quadratic formula. And this is what you call almighty formula. I don't know how this is almighty. How can this be almighty? When in formula,
Because anything you put in, you get answer. Correct, straight.
almighty. Small formula, we call this small formula
When it
almighty.
comes to quadratic question, anyhow they will set it. If you put them there, you get the answer straight away.
Now the roots x1 and x2 are real if the discriminant is non-zero. That's what we call non-discriminant. B squared minus 4ac, we call this discriminant. If the discriminant is non-zero, non-negative, that is if it is greater than or equal to 0, then it means that we're going to get real roots. And the roots that we are going to get are distinct. So you're going to get two different roots if my discriminant b squared minus 4ac is greater than 0. Now, if my discriminant is equal to 0, b squared minus 4ac is equal to 0, then it means that I'm going to get repeated roots. The roots are going to be the same. That is my s is equal to minus b over 2a is going to be the same, and I'm going to get y is equal to 0. So example of the two is when I have y is equal to s squared minus 2s plus 1. And this can be written as y is equal to x minus 1. And when I solve, when y equal to 0, I'm going to get my s to be equal to 1. It is repeated. So equating to 0, I'm going to get this. So I'm going to get s equal to 1 repeated. This means that the curve touches the x-axis at 1 point, that is s equal to 1. And its value is 0. So I'm going to get the point 1, 0. So this is the graph. So 1, 0. It's going to be like this. Okay. So that is repeated root. Now, if my x1 and x2 have complex roots, then the discriminant will be less than 0. So b squared minus 4ac will be less than 0. So in this case, either of the following two is applied. Either f of s is strictly positive, that is f of s is greater than 0. If a is greater than 0, this is illustrated as shown. Or f of s is strictly negative, where f of s is less than 0 and a is less than 0. Okay, so I think the graph didn't come. But we have a question here. We are to sketch the graph of y is equal to x squared minus 6x plus 5, indicating the axis of symmetry. Okay, to sketch this, we can write it in the standard form, or we can just use x is equal to minus b over 2a to get the axis of symmetry, and then we also use f of minus b over 2a to get the y value. That is my p and q. So here a is equal to 1, my b is equal to minus 6, and then my c is 5. So my s is minus 6 over 2 times 1, which is 3. Okay, Mr. Edu, John Edu.
Madam, please, my question is, when we are given a quadratic equation for us to solve, would they specify that we should use method of completing the squares, or we should use the formula, or we can just choose any of them, then we use this to solve?
No, we'll not specify, but it's unfortunate. I don't think we will even give you quadratic equation to solve.
Really? Oh.
Yeah. I cannot give you quadratic equation to solve.
Oh,
madam,
maybe we should find
madam, please, we can't transit. So.
Madam,
I can ask you to make this sketch. There's no questions. I mean, these questions have not asked you to solve any quadratic.
Yeah.
There's a quadratic question, Bamba.
Madam.
Quadratic question.
Madam. Hello, please, madam. Boss man, there bank one year po.
Madam Chirima, quadratic integration, dear ma.
Now, completing the squares, completing the squares, enough from Sao, using completing the squares now, enough from Sao.
Sure. I
was hyperbola.
I mean, who the that for I said, need that for.
Hey, boss man.
My brother, I suffer for a year, master.
Like we will get antidote for them. Don't worry.
Like one thing I've seen is that from the beginning, those who started talking, they have kept quiet up to this point because a form on this.
The thing, unless you follow.
Yeah.
But the network is not sometimes you go off like 5 minutes, but the time you come, then the place that you're supposed to understand the bypass the place. So you have to challenge. Hey, answer. If you did here, you know they understand.
Madam,
Charlie.
Madam, you left.
Madam, you left.
With the network. Yo, man, come on. Oh, yeah, madam, boy, me who.
Now you see, let me just
Is the lesson over?
Hey.
Not yet, please. Not yet.
Yeah, tell the body about long talk we have.
15 minutes more. Don't worry.
You this guy. You.
Why dear body about Potupa? Now go about the bush there.
First,
Hey,
the weekend is horrible.
Don't even say that. It's
They are
out
still
of the
recording.
that. We are learning everything. Dito.
Presidio men can share. So why you dinner or to no more? Castle.
700 slices.
Mentary, my
Why you rank all that?
That is where they are going to where they want to.
Cost me 700 slices. Hey.
Hello?
Hello.
Madam no best about na say one time ago.
You go break.
Jeremiah, you started now one of the ending. Jeremiah, started one of the ending. Yeah.
Enye better. Is the kojo?
These are not the things that we have not done before. We have all done this before, but how they are teaching, it be some way.
No, the problem is that it is online, so sometimes it's kind of you need to pay more. You see, online you will not pay more attention because there are a lot of things different. But if it is classroom, you are in the classroom focusing on the board and you are writing. Whilst the lecturer is writing on the board, you are also writing. So it's like you have that kind of connection than online.
But
Online.
Also, classroom. There are people who are in the classroom who didn't pay attention. Some will be pressing their phone. Masa, I don't know. Fine. Maybe say fine. Masa, fine.
Please,
You buy the talkies.
You know, guys, I believe one thing is that I think we all have degree. So I believe this certificate they should have make it flexible. Even the exam kuracha, the way they are treated on the quizzes and the exam is something.
Course no cry. Me jai na ya day. Me jai cry na me want to.
Me, let's go and do RME.
Righteous.
Madam Christiana.
Yes.
What's up?
Over there, you'll be playing drums and dancing.
Where are the ladies? Where are the ladies?
Oh, yeah, we are lost, so we can't talk.
Because if I not understand anything, you are just responding to madam. Yes, madam.
We are wasting our
Yes,
Bible.
madam. Yes, madam.
You see the network. Now that you are not doing anything, you see the network is on.
Yes, you are just responding. Yes, madam. Yes, madam. Yes, your girls. Yes, PCC. Gift Robin. Yes, madam. You are on tissue. Yes, madam.
The network is really bad. You see,
yes, madam.
Now that you are not doing anything, the network is on. By the time we start doing something, then the network will be messing up.
Yes, you're both yes, madam.
One thing you must notice.
Jeremiah.
Hello, Jeremiah. One thing that you must notice that yes, madam, no, is for somebody's contract. So those responding, it is their contract to respond. Please, I beg you, allow them to do their job.
Yes, madam. Especially the girls. Do you understand? Yes, madam. Especially Justina and Gift Obe. Yes, madam. Sister Mary, are you there? Yes, madam. Yes, madam. We continue.
Professor,
Elizabeth, Madam Elizabeth. Are you also part of yes, madam?
Oh, Madam Lady is also part. Yes, madam.
Elizabeth is the president for that contract.
Yehovah. Yehovah. Yeah. The guys have left the page. Justina, when is madam coming back?
I can't tell.
Master, ask the course rep.
Have you closed or what is the network problem?
I think it's network problem. She will come back. She'll come back.
Justina,
Maybe
you have not been talking. No.
Tola.
Because
I'm not getting anything. No. This must be it.
this one is pure imasu.
Next semester, lady. Next semester, lady.
Fair blood here.
Results in the buy and must send the course.
Gifty.
Yes, please.
Are you now? Yeah, now you are no ambulance. Wow. This one you cannot do. Wow.
Abeg, if you think it's difficult for you, Ejima, they do dondology. Come here, you go play drums and dance. Come and do it for Ejima dondology.
Maria, you cannot do wow again. No. Wait here.
But I told you, we can still do that.
A typical mass. A typical.
We'll do that. Wow.
Where they will do? Yes. As for here, there is ow.
Master, further algebra and further calculus is waiting for us. This one is just the beginning.
Please, do we have class after this one again?
No. I'm talking about the next block or next semester.
Charlie, we don't finish this semester, then you are taking off next semester. Finish this one.
No. The way you are kind of this. That's why I'm saying that.
You, the one in front of you, you don't finish. You are taking off another one. Finish this one before.
Jesse, do you have class after this? After this lecture, do you have lectures again?
Unless tomorrow.
No, please, you don't have class.
The one we have it done time, eh?
No.
Yes.
Today we only have one.
Time.
Done. What time? We better go.
Yeah, the day was very interesting.
Why? You don't want us to sleep, eh?
Charlie, I wake up at 6 o'clock. I realize that they're having class. I wake up 6 o'clock. They're having class. So I have to join. I join and I saw one question. You see, when I join, I've announced myself. They put I wake up so I realize that I told them, say, hey, I join, but I've solved one question for them. I've announced myself, so I put the question I've announced. They thought I've started the lecture with them. Meanwhile, I joined like 6 o'clock. They close 6:40 something or 50.
Bad man.
Please, where's the course rep? At least the course rep should try to reach madam. The course rep, please try to reach madam and see whether she will come back or not. So that you
my brother is to be frank, let's call it spade a spade.
I beg you, let madam confirm you know will come. So say
I'm there. Yes.
Maria, where do you stay?
Where do I stay?
You stay heaven.
You want to know where I am? I'm in Sampo.
Yes, so. Oh, you are
I'm at
Kintampo?
Kintampo. Yes,
Oh,
please.
which part of Kintampo?
I'm at Jema.
Ah, Jama.
Jema, not Jema. We have Jema, we have Jema.
Ah,
Master, you people for spare so.
I want to visit you.
I beg, the course rep.
You
Call
want to
madam then
visit
ask
me?
whether she will
You
come.
want to visit me
Yes,
when?
so
When?
Visit them for
anytime.
what? Visit them
Let's
for what?
next year.
Ah,
They are recording you guys. The recorder is on, please.
Hey,
I'm even
Ampao.
shocked. Uh-uh.
But who?
We are waiting for madam and then look at all this.
Charlie. Wow, madam is back. Madam, you are welcome.
You are welcome, madam. You have been missed.
and I will have missed you. Come back.
Madam is in. You have become back. He is in or he is in.
I'm back. Oh, I'm back. Was the
Yeah,
network?
you have missed me.
You're welcome,
Oh,
madam.
Thank you.
this
So please
network,
let's continue.
yeah.
Please let's continue. Okay, so we are to sketch the graph of y is equal to x squared minus bs plus x squared minus 6s plus 5. Then we indicate the axis of symmetry. Okay, so I think we will need the intercepts. X and y intercepts. And then also need the axis of symmetry. Okay, and then we need the vectors. So for a graph, quadratic standard form. Okay, so if I have y is equal to ax squared plus bs plus c, then my axis of symmetry is given as x equal to minus b over 2a. Here my a is 1, my b is 6, negative 6, my c is 5. So my x is negative 6 over 2 times 1, okay, which is 3. Therefore, the axis of symmetry is the line s equal to 3. Then my other points, so this is the same as my p. So to find my q is f of p, or f of my minus b over 2a. So this will give me, when I substitute 3 into the equation, I'm going to get minus 4. So my vertex is 3, 4. We can also find the end intercept by equating it to 0. So when I equate it to 0, I'll find two values that when I multiply, I get 5. Then when I add, I get 6, which is minus 5, minus 6, and then positive 1. Hey, is it 5? Sorry, 5 and 1. 5 and 1. So negative 5, negative 1 will give me, when I add, I'm going to get negative 6. When I multiply, I get 5. So my points will be positive 1 and then positive 5. That will be intercept. Then the turning points will be negative 4 and 3. So we sketch the graph. That's what we're going to get. So the graph will look. So the symmetry is the line requirement. The axis of symmetry is the line s equal to 3. Then I have the endpoint. It says find the following. Okay. So that's another question. To be it.
I just gone.
Master, be careful.
Yeah, na yebre.
Righteous, be careful. Be careful.
Me brain so mama kasa me brain. Ya pong. I just gone.
Mr.
Good morning. Good morning.
Morning, the good.
Yeah,
Yeah, Alex.
Yeah, my ICT people. Please, your calculus, you know, God willing tomorrow, into me ancient. But you better join me advance for no. I'm watching 4 a.m. Now phone 6:30. Now kwa algorithm. Now your class now 11:30 to 3:30 no. Kwa Monday 4 a.m.
Hey, Charlie, why this stress?
I am repeating myself again. The calculus now and 11:30 to 3:30 tomorrow no. After algorithm no. On to me NCIA. Monday 4 a.m. But
That is Sunday to Monday 4 a.m.
Yeah, 4 a.m. But it is advisable say Sunday now advance for your presentation. You enjoying it on 4 a.m.
Presentation be home.
And here advance for one class.
Like one way mathematics and Kassan.
Yeah.
Oh, okay.
And the ancient to say yeah, after algorithm no. Yeah, analytical no.
But this time I'm confused about all the courses.
Yeah,
you don't know
we are all confused. We are all confused.
Analytical,
Course rep, please. I am put this thing in the group and the link.
I will still
so
type
that
it on the
able
group,
to.
but I want everyone to hear.
Try to put it because most of them are also not here.
Yeah,
You
I will still
understand.
do that.
So we write it and put it in the group.
Yeah, I'll do that.
Yeah, hello, colleagues. My hand is up. I want to ask something. Please look at the nature of this blog now. I think totally I'm confused of everything. Today this, tomorrow this, today this, tomorrow this. Sometimes it baffles us. So. Well, you don't know. Sometimes they are on our way. See, go do this. On our way, go do this. So, what of if your network is not active? You think that you can, you miss. No, they should spare us with something. No, they should spare us. They should be specific to their time. Not that we are not just people like JSS people. We are adults, so they cannot. They should treat us as an adult. They should spare us with their time. They must be systematic. Today, this, tomorrow, this, today, this, tomorrow, this, tomorrow, this. No.
This particular block, West Coast Center, we are like everything has been disorganized when it comes to West Coast Center for ICT people. Everything has been disorganized for us.
UCC2 is part.
Yes, madam.
Because UCC at times you have to join us. At times they have a certain people that you have to join. For West Coast people, ours.
Oh, plagiar here is difficult. From the roadside. Oh, that one that you get.
It's too much. Ours is too much. Because for looking at if you take a critical look at the timetable for ICT mathematics, the things that we are supposed to learn for this particular block, we are not following it according to the timetable.
So why should they treat us like that?
And we have not even done half of them.
We don't even know. Sometimes we don't know what. Miss, I don't know even the process we are doing. We don't know. You go join this, you go join this. Why should we join advanced calculus?
But you hold your breath. You, Michael, Righteous, hold your breath. Please, course rep, if you are here, please try to reach Madam and see whether she will come back or not.
I'm
Please.
back. I'm back. It was my
Okay,
network.
thank you.
Okay,
Oh,
but
okay.
I'm sorry.
Okay, first your hand was up.
Yes, madam. We were not seeing anything, so I wanted to prompt you that whatever you are saying, we are not hearing from
You're
you.
not saying it.
Moreover,
Okay.
if you are going to end the section instead, since your network was disturbing you.
Please, I have 30 minutes, so I want to continue. Hello.
Yes, madam.
Yes, madam.
So we want to continue. So we're on this graph. Okay. So using the completing of squares, we got the graph. Okay, so we have this completing of square. We're going to get this. So my p is minus half, my q is 3 on 2. Okay. So my p is minus half, my q is 3 on 2, my a is minus 2. So it means that it's going to open downwards. Okay. And then the axis of symmetry is the line s equal to negative half. Okay. It says that since a is less than 0, it has a minimum value of f of s is equal to 3 on 2 for x. So the question says that show that for x in R, f of x is equal to 3 on 2. So f of s equal to 3 on 2 is our maximum. We've been able to show that. And the line of symmetry is s equal to minus 1 on 3. And the turning 1 on 2. And the turning point is 1 on 2, comma 3 on 2. So that is this. When you sketch, okay, and then we find the 0, 2. So the zeros, either we just use the quadratic formula or any approach. But when you solve it, you're going to get your x to be minus 1 on 2 plus or minus square root of 3 over 2, which is 0.23 and then negative 1.23. So these are the two values that you're going to get. So the graph is going to be like this. So this example 3, please, you can take your time and go through the example 3. It follows the same procedure. Okay, so the next thing we want to look at how to derive the quadratic function from the root. So assuming you are given the root of the quadratic function and you want to find the function itself, it says that let x be equal to x1 and s equal to s2 be the root of the equation as squared plus bs plus c equal to 0. Now, if I divide through this as squared plus bs plus that, I'm going to get my s squared plus b over as plus c over a equal to 0. Okay, so this is the equation. And we are told that x1 and s2 are the roots of the function. And we know that anytime we find the roots of a quadratic equation, we can write it's written as x minus x1, x minus x2. So for even example here, okay, so this is an example. You see that when you solve, you're going to get the function is t squared plus 4t minus 12. When you solve, you're going to get t minus 2t plus 6. These are the roots. This and these are the roots. So negative 2 and 6 are the roots. So if my roots are x1 and x2, then I can write it as x minus x1, x minus x2. Now when I expand this, I'm going to get x squared minus x x2 minus x1 plus x1 x2 equal to 0. So this is the same as x squared minus x1 plus x squared minus, you open a bracket, x1 plus x2, you close the bracket, x plus x1 x2 when you compare this equation, Foster, your hand is up.
Yes, madam. Madam, please, from this section, this is equivalent to open bracket x minus x1 close bracket another bracket open x minus x2 equal to 0. Why is the x minus x2 not plus?
So we are saying that from here, we are saying that the roots of the function are x1, s equal to x1, s equal to x2. So if I want to write it, if I have the roots, Pastor, I will cane you. This one there, you don't have to ask me. Pastor. So if I have the root to be s equal to x1, and then s equal to x2. If I want to write it in the factor form, this one is x minus x1, and this is x minus x2. And I want to say,
Okay.
so if I multiply
Because you
the
compared it
two,
to the earlier one, that's why I dropped that question. Thank you, madam.
you're welcome. Okay, so let's continue. So as I said, I have the factors to be x1 and then x2, the zeros or the roots. So when I write it in a factor form, I'm going to get x minus x1, x minus x2 is equal to 0. When I expand, I'm going to get something like this. Now, when I compare this, the equation 3.2, equation 3.2 with equation 3.1, I can see that my a over b is equal to minus x1 plus x2 because I have a coefficient of x here. Okay. And my c over a is equal to x1 times x2. So by comparison, I'm going to get my a plus b, x1 plus x2 to be equal to negative b over a, and then x1 times x2 to be equal to c over a. So the relationship between the roots of the quadratic equation and its coefficients is summarized as follows. So if x1, x equal to x1, s equal to x2 are roots of as squared plus bs plus c, then my x1 plus x2 is equal to minus b over a, and then x1 times x2 is equal to c over a. So that is it. So if I want to this equation, if I multiply through by a, I'm going to get as squared minus a into brackets sum of the roots x plus a times the product of the roots. So that's how to go about it. So example, we want to find the quadratic function whose roots are 1 plus root 5 over 2 and then 1 minus roots 5 over 2. So we have x1 to be 1 plus root 5 over 2 and then s2 to be 1 minus root 5 over 2. So I have to find the sum and then the product. So when I find the sum, I'm going to get 1. And then when I find the products, I'm going to get negative 1. So to write the equation, I know the equation is as squared minus a sum of roots x plus a product of roots. So my a here, there's no a because my a is 1. Because I have a is supposed to be, the sum is supposed to be a over b minus a over b, but the answer is 1, so it means that my a is 1. And then the c is supposed to be a over b, so my a is 1. So here my a is 1. So when I substitute, I'm going to get as squared minus a, the sum of roots x plus a product of roots, and my a is 1. So I have s squared minus So the minus is still here. Then the sum of roots, I had 1 plus, and then my a is 1. And then products of roots, I had minus 1. So the function will be s squared minus x minus 1. So that's how to go about it. There's another one. It says that a quadratic function has the zeros to be 1 over m cubed and then 1 over n cubed, where m and n are the roots of this quadratic function. He said, without solving the equation, find an expression for f of x. So first, want to find, so the question, we want to find the equation of a quadratic function. Okay, we want to find a quadratic function which has the root to be this and this. That's the question we are solving. But the question goes further to say that m and n are the root of this function. So we have a quadratic function. So the function is this, 3x squared minus 2x minus 1. This is the same as this. Now, when I compare this one to the standard equation, ax squared plus bx plus c, I can see that the sum, which is m plus n, is equal to minus b over a. So I'm going to get minus b over a here. My b is minus 2, my a is this. So this minus 2 over 3, which is 2 over 3. And my product is c over a, which is, my c is minus 1, my a is 3, which is minus 1 on 3. So with this in mind, I want to find the equation for the quadratic which has the root to be 1 over m cubed and 1 over n cubed. So that I have to find, for that quadratic, I have to find the sum of roots and then the product of roots. So the sum of roots, so let x1 be this and x2 to be this. So the sum of roots is 1 over m squared plus 1 over n squared. When I simplify this, m 1 over m squared plus 1 over n squared, I'm going to get I'm going to get m cube plus n cube divided by m cube n cube. Now I want to express m cube plus n cube in terms of, because in the here I have the sum and then the products, but I don't have m cube and an n cube. So I want to express this in terms of the sum and the product. So to do this, I will use I don't know. MAT101D. I say we should not be brave because it is not easy.
Okay.
To even get that, we have to use the binomial theory. So I will write m plus n cube. And by the binomial theory, I know that I can use the Pascal triangle. The Pascal triangle, can somebody give me the Pascal triangle? When it is, so I have a, okay, so let me make it m plus n. If it's to the power 0, it is 1. If it's to the power 1, it is 1, 1. If it's power 2, it is 1, 2, 1. To the power 3 is 3,
Power
3,
3 to 1, 3, 3, 1.
Okay. So if I have m plus n to the power 3, this will give me m to the power 3 plus 3 times m squared n plus 3 times m n squared, then plus n to the power 3.
N cube, yes.
Then in what I just did, I got something like m plus n squared. So I will make m plus n squared the subject. So I'm going to get, m cubed. So I'm going to write m cube plus n cube. This is equal to, so I take this one out. This is equal to m plus n all cube, then minus 3m squared n squared plus 3m n squared. Then I can simplify further.
Madam, does it mean the leading n should be cube? You made it square.
Please excuse me. Hello. Prof, have you come back to I could maybe 11. Maybe 11 methods is here.
Hello, madam.
Does that mean what?
Your madam, please back to your expression. The word. Yes. You made it m cube plus n square.
Oh, sorry, it's supposed to be cube. Sorry.
Thank you. Thank you.
So this is m plus n cube minus, so I have 3 here, 3, so I can subtract 3. I have mn, so I have m n here. Then this will be left with n, and this will be left with m. Which one is n? Which one is n? Okay, so this is m squared. So please let me clean it. So I have m squared n, and then I have m n squared. So if I factorize this one out, then this will be left with m plus this will be left with n. Okay. So we can substitute that. Okay. So in place of m cube plus n cube, I will substitute what I just did. Which is m plus n all cube minus 3mn into brackets n plus n. So that's what I'm doing here. So I'm substituting m plus n cube minus 3mn into brackets n plus n. Then all divided by, so it is divided by m cube n cube, and is the same as mn all cube. Now I know the value for m plus n. The value for m plus n, I got it from here. It's 2 on 3. And then mn is negative 1 on 3. So I do the substitution. This is 2 on 3 cube minus 3 into brackets minus 1 on 3. And then times 2 on 3, all divided by, that's supposed to be minus. So minus 1 on 3 cube. So you expand and you're going to get 8 over 27 plus 2 over 3, all divided by minus 1 on 27. Then when you simplify, you are going to get minus 26. And that is for only the m1, x1 plus x2 is the sum of the roots. So I find the product of the root. Product is 1 over m cube times 1 over n cube, and which is the same as 1 over mn cube. And this is 1 over negative 1 over 3 cube. And this will give you minus 27. So now I have the sum, I have the product, and then I can quote the formula. So I have x1 plus x2 is equal to minus b over a, which is equal to minus 26. So it means that my a is 1. So I do the substitution. I have as squared minus a into brackets x1 plus x2 into open, we close the brackets x plus a into x1, x2 is equal to 0. So I know my a is 1. So I have s squared minus into bracket 26x plus minus 27 is equal to 0. And this is the equation I'm looking for.
Yeah, hello, madam.
Hello.
Yeah, hello. Madam, please go over it again. The later part, the last part, the last session, getting to the
The
conclusion.
finding the product.
Yeah, combining the two to find the product to the equation. The later part of your submission, please.
Is it this one?
Yes, please. No. From where you fixing the n values. Yeah. This place, from this place going, please.
And so we know that m plus n is 2 on 3. We know that the product is minus 1 on 3. Then the sum is 2 on 3, all divided by the product cube. Product is, please, this is minus 1 on 3 cube. So this one is expand and simplify. So when you expand and simplify this one there, you're going to get minus 26. And then the product is 1 on m cubed times 1 on n cubed, which is the same as 1 on m n all cubed. And that's 1 over negative 1 on 3 cubed. And when you simplify this one too, you are supposed to get negative 26. Then you know that when you compare the sum of roots to the general formula, it is sum of roots is equal to minus b over a. But I got negative 26. So negative 26, it means that my a is 1. So I go and then do the substitution into the derivation that I got. So I have my a to be 1. So I have s squared minus, my sum of roots is minus 26, plus my product is minus 27. So this is s squared plus 26s minus 27 is equal to 0. Mr. Boating, hand this up.
Yes, madam. Madam, please, I want to know where you introduce the x1 and the s2. Is it the same as the alpha and the beta?
Yes, please. Yes, please. The same thing.
Okay, then thank you. I'm okay.
Okay. So the most important thing is your understanding. So remember at the SHS, I think it's on Aquila. Aquila decided to use alpha and beta. So you can use A and B, you can use tables and chairs, you can use trees and buildings, anything to represent your factors. So the factors are actually things. It can be trees, it can be anything. So if you decide to use alpha and beta, is the same. If you decide to use x and y, x1, x2, you can decide to use p and q. It's the same thing. So the most important thing is the understanding the concepts. Please, can I continue?
Yes, please, madam.
Okay, so we have about 2 questions. You can go through them and then we'll see. Okay. So the next, we want to start with the polynomial functions. So the linear function and then the quadratic function, they are all polynomial functions. They are special cases under polynomial function. So a polynomial function is generally defined by a sub n s to the power n plus a sub n minus 1 s to the power n minus 1, add all to the constants, where ai's, so ai's are in R, and then my I is supposed to be from 0 up to n, and all of them are supposed to be greater than 0. So my powers are supposed to be positive, non-negative integers. P of s is said to be a polynomial function of degree n, written as degree of P of s is equal to n. And the a sub n, we call it the leading coefficients. So polynomial function, let's n be a non-negative integer and a sub n minus 1 up to a sub a naught be real numbers with a sub n not equal to 0. Then the function given as this is called a polynomial function of degree n. So when we take the polynomial function, we want to look at some operations and then some characteristic of the polynomial function. So every polynomial function has a smooth curve. So we can look at the straight line. It's also a special type of a curve. Okay, and we can see that it is smooth. There's no break. When we take the quadratic curve, it is also smooth. There shouldn't be any break. Cubic functions should be smooth. So all the graphs of polynomial functions are, or they all have a smooth curve. If the polynomial, if P of S is a polynomial function of degree n greater than 0, then the graph of P of S intersects the x-axis or any line in the plane in at most endpoints. Okay. So if n is greater than 0, then it should intersect it at least endpoints. At most. So figure 4.1 and 4.2 show the graph of polynomial functions of degree. Let me see if I have those graphs. Please, we'll get there. Note the distinction between the shapes of the graphs in 4.1 and 4.2, particularly in 4.1. The leading coefficients A sub n is positive, whilst in 4.2, the leading coefficient is negative. So please, let's go to figure 4.1 and figure 4.2. Okay, so this figure 4.1. Figure 4.1, where is it? Okay, so we are even here. It says that if the leading coefficient is greater than 0, then the graph looks like this. So this one. First, we want to look at where the n is odd. When n is odd, then A is greater than 0, the graph looks like this. If my leading coefficient is less than 0, then it will look like this if it's odd. Now, if my n is even and the leading coefficient is greater than 0, then it will be like this. Just like for quadratic, we know that if a is greater than 0, then it opens up like this. So the same thing, if it's even and then a is greater than 0, then the graph will look like this. If it's even and then the a is less than 0, then the graph will look like this. So please, let's pay attention here. If it's even and then a is greater than 0 is like this, less than 0 like this. A greater than 0 like this, odd, and then less than 0, so it rises, it's like this. And this one, it falls like this. It says that for large values of it, the graph of f of s looks more and more like the graph of its leading term. For example, we observed in the previous chapter that the second degree polynomial, that is y is equal to as squared plus bs plus c, is just a translation of y is equal to s squared. That is the quadratic. A zero of a polynomial is any s value s naught for which f of s is equal to 0. So the zeros of a polynomial, we just equate the function to 0. So under the polynomial, we can have sum. We can add two polynomial functions. Okay. That is, evaluating the polynomials and adding results is the same as adding the polynomials and evaluating the results. So if I have P of S with degree m and then Q of S with degree n, such that the degree of the m is greater than 0, then the polynomial, the addition will also have degree m. We can also multiply two polynomial functions. Okay. So when we multiply the two, then the degree will be the sum of the leading, the higher degree of the two. So if P of S has degree m and Q of x has degree n, then the product will have the degree m plus n. Then we can also, if x is equal to a, is a zero of 0 of P of S plus A. This point will be, okay, so we are saying that we explain this one later. And then we can also divide polynomial functions by a process called long division. If a polynomial function is divided by another polynomial function d of x, then it yields q of x and r of x, where r of x is my remainder, and then my d of x is my quotient, my q of x, and my d of x is my divisor. Okay, and we are saying that d of x should not be equal to 0, and the degree of my remainder should be less than the degree of my divisor. Okay, so q of s is the quotient, d of s is the divisor, and then r of s is the remainder. Okay, it's already 11 o'clock.
Yes, madam.
We want to end here, but we've gotten to division of polynomial functions. I want you to revise divisions of the polynomial functions. Okay, Kweku Buama, your hand is up.
Hello, madam, please. The slides, last time you promised to send it to us. I don't know whether my colleagues are there.
No, we don't have it, bro. I'm about to ask the same question that we have asked.
But there's a one, this switch class. They have the, are you not on this platform? They notice it.
It's not there like this. That one is
No promise to send
PDF one, not the slide. You have the PDF.
But this one is also PDF.
Madam, this one is different from what we are having here.
This is even 102. I've sent both 102.
Madam, we have two classes here.
Madam, please.
So I don't have the other class. So how do I send it? Because it's here. Switch.
Madam, please, what page?
Madam, please resend it to solve issue. Madam, please resend it.
But the content is the same. Just that Madam's own is in, is it chapters or lessons?
Hey, my uncle, what I sent is the same. Algebra.
The class you are showing is for UC class.
It's the same thing, but just that our own is
And so
combined.
I don't know. Okay, so it's here. So I don't know how you're going to get it. Switch 3.1. So if you can get your friend's numbers, you can send it to them. Please, it's here.
Miss Alex, please chat, madam.
Michael or Michael. So Michael is Michael.
Hello, madam.
Michael, madam.
Yes.
Hello, madam.
Yeah. Please.
Yeah,
We
please.
can
After this class, I'll send you a hi.
to us in the group. We will download it and go to. Because what I'm having on my laptop is the other one. That's the PDF one, different from this one.
Hello, madam.
Content. But this what is a bit summarized, a bit summary than the one I'm having here.
Says who? Because that's what is it not the same thing? Let me open it. It's the same thing. It's the same thing. Oh, is it not the same thing? It's the same thing, no, uncle. It's the same thing. It's the same thing. It's the same note.
Madam, it's the same thing, but yes, that our own is combined.
So 101 is combined, though. 101, everything is combined. I have algebra and trig week 1 to 5, week 1 to 3 is combined. Then I also have week 4 to 5. So please, it's combined. Even my notes is combined. This one is combined. Okay, please, any other?